In this video, we're going to take a look at water, acids, and bases. So we're going to start with water and just some simple kind of everyday knowledge pieces of water. So almost 75% of Earth's surface is covered with water. The majority of that is ocean water. 3% is fresh water, so the 97 plus the 3 gets us the 100. Of this 3% fresh water, most of it is in ice caps and glaciers. Second, we have groundwater, and then lastly, we have about 0.3% is in surface water. That surface water can get further broken down into about 87% is found in lakes, 11% in swamps, and 2% in rivers. So when we look at water, it refers to H2O's liquid state. The solid state of water is referred to as ice, and water vapor is the gas state of water. More basic properties of water is that it is tasteless and colorless, and more importantly, it's that it is transparent, meaning that light can move through it. This is important for aquatic organisms, especially aquatic plants that need the sunlight in order to do photosynthesis. Looking at the chemical structure of water, we know that it is made up of 2 hydrogen atoms and 1 oxygen atom. One of the properties of oxygen is that it attracts electrons. So the electron or the oxygen atom actually attracts the electrons more strongly than the hydrogen atoms. So this red oxygen atom is pulling the electrons from the hydrogen over to the oxygen. This gives the oxygen atom having a slightly negative charge and the hydrogen atoms having a slightly positive charge. And we call this polarity. Polarity is the difference in electrical charge between different parts of the same molecule. So overall, this whole molecule has a net 0 charge. But if we look at it specifically, we'll see that the oxygen atom is partially negative because it's pulling all the electrons, and that leaves the hydrogen atoms partially positive. So this comes into play in some of the special properties of water. So first of all, we have to remember that opposites attract. So the positive hydrogen atoms are going to be attracted to the slightly negative oxygen atoms of a different water molecule. That little force of attraction right here is going to create something we call a hydrogen bond. And this is a type of chemical bond that forms between molecules. It's not as strong as the bonds that hold the hydrogen to the oxygen atoms, but these hydrogen bonds are fairly strong, but they tend to get broken if you were to move water. It's what allows water to move. So water molecules tend to stick together, and this is due to those hydrogen bonds. They don't want to separate. It also is why water has a relatively high boiling point of 100 degrees Celsius, and that's 212 degrees Fahrenheit. And so when you boil something, you're breaking those hydrogen bonds, and then those free molecules are escaping as a gas. And so this is why most water on Earth tends to be liquid rather than a gas, because those hydrogen bonds keep it as a liquid. Water will expand when it freezes. And this is odd because normally when things cool, they shrink. And so water is the one exception here. This causes ice to have a lower density than liquid water, and it allows ice to float. We've all seen ice water where the ice floats. And also here in Minnesota, we see ice floating on a frozen lake all the time in the winter, and this allows fish to survive, fish and other aquatic organisms, to have space beneath the ice where they can still swim and survive. And again, this water expanding when it freezes is due to the hydrogen bonds. So when we look at acids and bases, both acids and bases are really solutions, and solutions are mixtures that have the same composition throughout. Water is often the main ingredient in many solutions, and it's even true for acids and bases. So if we have just pure water, a tiny fraction of the water molecules will break down to form what we call ions. And so ions are partially charged atoms, or not really atoms, partially charged molecules. And so we have to indicate the charge. And so when when water breaks down, it forms this H3O plus ion, which is called a hydronium ion. And it produces a negative hydroxide ion. And so when we're looking at acids and bases, we look at the acidity or the concentration of that H3O plus or the hydronium ion. Pure water has a concentration of hydronium ions that is very low, like 1 in 10 million water molecules will break down to produce a hydronium ion. So it is essentially neutral, and we give that a pH of 7. And we use this pH scale to measure acidity. And so I'm hoping, as a refresher, you've seen the pH scale before, and that water is neutral at 7. As you decrease numbers, your acidity goes up. As you increase numbers, your basicity increases. So acids are solutions with a pH lower than 7. And these are solutions with a higher concentration of hydronium ions than pure water. So as the hydronium ion concentration increases, the pH value is going to decrease. So remember, a low pH value indicates a strong acid or a high concentration of the hydronium ion. Acids tend to have a sour taste to them, and very strong acids can be damaging. So, for example, your stomach acid is a very strong acid, and it would eat through the stomach if it were not lined with a layer of mucus. This mucus layer protects your stomach tissue. Bases then are a solution with a pH higher than 7, and they have a low concentration of water, or a lower concentration of hydronium ions than water. So an example would be baking soda. Baking soda is a base. Bases tend to have bitter tastes, and strong bases can also be harmful. Lye can burn skin. Bleach can remove the color from clothing, and both of these are strong bases. So the strength of bases, as the hydronium ion concentration goes down, the pH value goes up. We have that inverse relationship again. So most enzymes in organisms can only function at certain pH values. And so cells will either secrete acids or bases in order to maintain that proper pH. So for example, there's an enzyme called pepsin, and pepsin needs an acidic environment, which is great for your stomach. So pepsin helps break down food in your stomach. But then when the stomach contents need to enter the small intestines, that acid needs to be neutralized because the enzymes in that small intestine can only function if it's basic. So we have an organ called the pancreas that will secrete a strong base into the small intestine to help neutralize the acid. So then the enzymes in the small intestine can function. So in our human body, about 70% of the human body is water, and it's needed to dissolve many of the substances that organisms need in order to survive. It's also necessary for many biochemical reactions. So 2 examples of biochemical reactions that use water would be photosynthesis, where water is the reactant, and then cellular respiration, water is the product. And so that's why these 2 reactions kind of work together. One supplies the product so the other can have the reactant, and it's kind of just a cycle.